on this computer. Okay, and we have this live transcript. All right. Okay, hello everyone. This is our first optional, not a mandatory, class meeting / office hour. So I will be here every Monday, 2 to 4 p.m. to waiting for you and to address your questions for the past week and the coming week. Usually I will use the first like 10 minutes, 15 minutes, okay, maximum half an hour to go over the lectures. We didn't have enough time in my solo presentation video to include enough details there. So I want to use the first half an hour to, make up those details. And another thing is, I want to welcome you to our class. This is a class about weather and climate, and really appreciate you share my passion. Uh, Weather and climate is one of my favorite fields. I seriously consider to get another PhD or master degree from UCLA or UC Santa Cruz. Those universities, they have very good meteorology program. That is my goal, my education goal, professional development goal. So I can't wait to share what I have known, what I have learned with you. Okay, so I hope you enjoyed the first week of our class. You enjoyed playing with windy.com. Yes, I love that website. It's just so awesome. And I hope you enjoyed it too. But I heard that some folks in our class, they have some like questions about windy.com. So I will go over windy.com with them after my presentation. Okay, and like I said, this is optional office hour. You don't have to come if you have other commitment. I know some of you have classes or other things, but I highly recommend because you will learn much more details and stay engaged more in this class. Okay, so that is, I hope you can come. I'm also a people person. I love you. I love seeing you. You definitely cheer me up if you come here. So I really appreciate you. Okay. So like I said, today, the first half an hour, I want to go over one very, very important thing you're going to use in the coming week for your discussion number 2, which is station model. So let me share the screen with you. Okay. All right. Do you see my screen? Yes. Okay. So I see one in the chat. Yes, it's very cool. All right. So let's go to our class. All right. So this is the first one. Okay. So let me first open this discussion number 2. So it's a little bit different from last week and also from my last semester. If this class was recommended by your friends, it's a little bit different. Okay. All right, but you will have more fun. I guarantee that. So for this week 2 discussion, our goal stays same. We want to summarize what you have learned in week 2. Okay, which is the remaining bullet points on my lecture presentation. I go over that lecture presentation fully last week. So you just need to use the same video, okay? And you can see, again, you need to compose 2 posts, okay? But you don't have to write that much. In this initial post, you are going to draw 2 pictures. So I will ask you to use this worksheet. So you can see, you can download this worksheet right here. Okay, you can keep downloading. And if you want, you can print it out. You can draw on the paper and then snap a picture and include that picture in your initial post. Okay, so let me download it. Okay, let's download it to the desktop. have that already. Okay, here we go. All right, so you can see I made this chart for you, okay? And well, excuse my ugly drawing, but it's supposed to be a chart, okay? So you can see the y-axis, the vertical axis is your altitude. Unit is kilometer. So we measure from the ground, starting from 0 all the way to 160 kilometers above the ground. Okay, and the x-axis stands for temperature. Okay, we measure that in Celsius. Sorry, I know many of you are used to Fahrenheit, but in meteorology, we need to follow the international unit. We use Celsius. Okay, so if I used to, you need to convert. Actually, the converting is very simple. Ask Professor Google. but here's the formula. Okay, you use your Fahrenheit minus 32 divided by 9 times 5. Then that is Celsius. Why I know this? Because when I first come to United States in 2010 from China, one of my classmates, she's always like mentioning, oh, Jing, today is very, very cold. It's like 50 degree. I was in Madison, by the way. I'm like, 50? Are you kidding me? I grew up with 30s, 38 is the hottest day, but I grew up with Celsius. Okay, so convert it. So I learned it how to convert Celsius and Fahrenheit. Okay, it was a challenge, but not a challenge anymore. I learned something from the challenge. So never afraid of your challenge. Okay. All right, so you can see what I want you to do on this picture, right? I want you to plot how the temperature change as you go up. Okay, at different level, because in our lecture textbook, let me go back right here. Okay, in your textbook, one of the textbook or both actually, they have similar drawing. Okay, so you can see in the troposphere, right? That is one layer in our atmosphere. We are living in this troposphere. As you go up, temperature decreases. And then in the stratosphere, temperature increases. And then decrease again in your mesosphere and then thermosphere, right? And you will see different things in different layers. So in your discussion, your picture here, let me make it a little bit larger. View, page width, okay? So you can see, I want you to use the textbook to learn the vertical temperature variation pattern in atmosphere, okay? And draw the temperature curve on the graph above, okay? Your picture should like look similar, the curve should look similar to the one you see in the textbook, okay? And then I want you to draw thick lines, okay? This means thick lines, you just draw that, okay? To show the position of tropopause, stratopause, and mesopause. As you can read it where it is, the height in your textbook, okay? And I want you to use the wavy lines, to shade the region of ozone layer. So for instance, okay? So for example, you read it, okay, ozone layer is about here. So let's draw the wavy lines, okay? You can draw the wavy lines like this. I'm not using my mouse, so excuse me. Like this. So you should shade the entire region, okay? The entire region from the top to the bottom, okay? Of ozone layer. And same thing about our ionosphere, okay? Ionosphere, but use different lines. Let's use diagonal lines, okay? And I want you also to draw in Mountain Everest. You know, Mountain Everest is a mission impossible for most people, right? If you want to climb Mountain Everest, it's a mission impossible. It's the highest mountain on the earth. But let's compare it with the scale of atmosphere. Okay, I want you to use this question to appreciate the thickness of our atmosphere. Okay, even the thickness, the vast universe. Okay, so you can see Mountain Everest, this about like 8,848.9 meters. Okay, that's the top. So I want you to draw in Mountain Everest using the scale, the vertical scale I plotted here in kilometers. So it's about like 8.8, you know, 8.8 kilometers above the ground. So our Mountain Everest, let me zoom out a little bit. View. Come on. Here. 100%. Okay, so you can see the entire picture. Okay, the top, the summit of our Mountain Everest, if this is 10 right here, and your Mountain Everest is about here. So this is our little Mountain Everest compared to the entire atmosphere. Okay, so Pachamama is amazing. Atmosphere is amazing. Okay, so use my questions. You need to draw in, let's see, 1, 2, 3, 4, 5, those 5 things. Okay, so that is your first drawing. After you finish, you take a picture, include it into your initial post. Any questions by far? Okay, seeing no, let me continue. Okay, so this is your first one. The second picture is this station model. Okay, the station plot. Why this one is important? Because this one, well, we're going to use it throughout the semester to understand our weather. Okay, so you can see here, this sample plot actually is provided by our National Weather Service. Okay, meteorologists, they use a lot because on the map, they couldn't, they just can't, you know, have the table like this one. I asked you to fill it out. This one, it just takes too much space, right? We want to put everything, all the measurements about our weather into one model. Don't be overwhelmed by that model. That sounds scary, but it's just the way we draw it. It's just a picture, okay? So you can see it's a station model. This is the sample station plot. But we need to follow conventions, right, in order to understand each other. For example, our class convention is English, the language, right? So I have to speak English. I cannot speak Chinese, right? So we need to follow the rules here, okay? So let me introduce those rules. So that is the filters, okay? So you can see, oh, I need my annotation, and I want to change a color to black. Okay, so you can see this circle, okay? This circle should be placed at one location, okay? So that can be LAX, that can be, you know, UC Santa Barbara, wherever you have this weather monitoring station, okay, where you gather those measurements, okay? It also can be your backyard, okay? And you can see this circle can be shaded, okay? That means your sky cover. So the percentage of the sky covered by cloud, okay? So in this case, now I'm looking outside, okay, from my apartment, I see no cloud, then I shouldn't shade it, okay? You just leave it as, you know, hollow, okay? But the picture I sent you in my welcome message for this week, did you see that picture? Yes, yes, it's amazing, right? Let me show you. Announcement. Okay, welcome to week 2. All right, yay, this is my favorite picture. I took it from here, from my apartment. But you can see this called stratocumulus. Okay, but in this case, if I want to indicate the sky cover, you can see, wow, the entire sky covered by this sheet of cotton balls, right? Okay, so then I should fully shade this area. Okay, you should shade it completely. I should have a pen or something, right? Okay, but if the sky is covered by like a quarter, you shade like this. You just shade this part. Okay, a quarter. Okay, half, then this is half. Does that make sense? Okay, all right. Okay, so this is your first one. Delete all my drawings. Let's go back. Okay, and then we want to know the wind, right? Okay, so the wind is indicated by this bar, okay, by this, we call that shaft, okay, this long bar. But we don't draw that randomly. We should use this long one to indicate where the wind coming from to our station. Okay, so you can see in this case, you should draw your compass. Okay, so let's see. This is north, this is south, this is west, this is the east. Okay, it's easy to memorize. Never eat sour wheat. This is my teacher. He taught me this way. Never eat sour wheat. Okay, so you can see in this case, if you place the same arrow here, you can see your station, you are standing here, right? This bar coming from northwest direction. So we call this wind northwest wind. Okay, where it coming from. So that is how we name the wind, it's convention. Okay, and you can see we also have bars here. This basically in this, well, then that should be the tail of the wind, right? This the head heading to you. So at the tail, we indicate the speed of the wind. Okay, so this long barb, okay, this long barb represent 10 knots. Knots is a little bit longer than a mile per hour. Okay, 10 knots. This little one is 5 knots. Okay, 1.13 something. 1 knot equals to that many miles per hour. Okay, and sometimes you see those little flags. That is 50. That is 50. Okay, so this is 50. Okay, and then if you see all of these together, you should add them up. So in this case, your wind speed should be 10 plus 5, 50 knots from northwest wind. Make sense? Calder, it's good? Yes, great. Yes, easy. All right, so this is the wind. Okay, other parts is very easy. This is your temperature. Okay, in US, we use Fahrenheit. Okay, this is dew point temperature. Okay, last week, I remember that is, I think it's Albert or another student. Okay, he asked me, what is dew point temperature? Dew point temperature is the temperature you make your air saturated with water, which means if this temperature is equals to this temperature, you're going to see rain or snow, okay, whatever type it is, okay, because your air is saturated with water, they cannot hold more, you will see rain participate, okay. So, but we will learn that in our moisture chapter, okay, our precipitation chapter. And then you can see it's almost same. So you can see here the weather, 3 dots. 3 dots is moderate rain here. So you can see here, we use those symbols. There's a lot of symbols you can use to indicate the weather. Okay, to indicate the weather. All right, so this is weather on this side. Okay, you should put temperature, dew point temperature, weather. Oh, sometimes people also have a number in front of weather. So for example, 10, that is your visibility. Okay, 10 means 10 miles. 10 miles, yes, can be kilometer. It's up to, you know, your key. Okay, your model key. So that means from your standing point, your station, how far you can see. Okay, how far you can see. All right, so on the other side, we basically just indicate pressure. Okay, air pressure and the pressure trend. Okay, how pressure change in the past 3 hours. It's not, you know, in the future. It's not a predicting. It's not a prediction. It's in the past. Okay, so you can see here, well, 107, -6. It's not the number you should use. Okay, for example, I ask you, Carter, what's the pressure here? You shouldn't say 107. No, that's wrong. Okay, we should convert it. This is you know, like a naming, or it's a convention how meteorologists, you know, they record the air pressure and pressure change. Okay, so here is the rule. I also indicate in my lecture presentation last week. Okay, you should follow 3 steps. Number 1 is you should divide. Okay, sea level, not seal, sea level pressure by 10. Okay, then if you divide it by 10, what do you have? You have, let's see, let me use a, yeah, black is good. You have 10.7, right? 10.7. And then the second step is you put, okay, put 2 numbers in front of the result of from step 1. Okay, so what do I mean by that? Well, let's copy what we have from step 1. We have this 10.7, right? Okay, then you should put 2 numbers. One of them is 9. So 9, 10.7 is one of the results you get from step 2. Okay, the other one is 10. Okay, 1, 0 in front of it, don't add it. Okay, oh, let me change the color. And then in front of your, you know, the result from step 1, you have this, right? Okay, and then you compare those 2. One is 910.7, the other one is 1010.7. You compare step 3. Step 3, you should compare the 2 numbers, the 2 results from step 2. Okay, with mean sea level air pressure. Okay, which is 13.25. Oh, why it doesn't show up? Okay, let me change the color. Okay, which is 13.25 millibar. Okay, we all use millibar. So see which one is closer to 13.25 millibar. Which one in this case? 10.7, right? So in this case, your final result, okay, finally should be this one. Okay, this is Carter will use. Okay, you use this one. He will say, Jean, your current air pressure is 1010.7. Okay, yeah. And well, then this is pressure change. You need to divide this number by 10 as well. So it's not 6, it's 0.6. Then it's increase or decrease? Well, you have negative. Negative means decrease. Okay, decrease. So that means in the past 3 hours, your pressure decreased by 0.6 millibar. Okay, millibar is a unit to measure your air pressure. And this little symbol also indicates the same trend. Okay, you can see it's decrease and stay stable. Okay, if you see a symbol like increase, like this, increase, stay stable, or increase, decrease, like this. Okay, so that is a symbol language to show you the past change. Okay, I believe it's here. Okay, you can see it's right here. Okay, pressure trend. Okay, so and also sky cover. Okay, sky cover. Okay, so this is the thing. This is the station model. Any questions by far? Okay. Yes, Alex.
Could you explain the step 3 again for the sea level pressure?
Step 3, you just need to compare those two digits, those two numbers, 10, 910.7 millibar and 1010.7 millibar. See which one is closer to 1013.25 millibar. So which one is closer? The difference is smaller. Alex, which one?
Where would you get the 1013 number?
Oh, that is a constant. That is the number mean sea level air pressure.
Okay, thank you.
Okay.
Question.
Ryan. Yes. Oh, Connor.
So the 9 and the 10 are always constant?
Yes, that is a convention.
Okay.
The red number I put it here, they're all convention, they're all constant. You don't have to change that.
And then the MSLP, the 1013.25, where did that number come from?
That is global average. We measure mean sea level air pressure at millions of places all over the world, and then we average out. More or less is this one.
So that is also constant then?
Right, exactly.
Awesome. Okay, cool.
Yeah.
Thank you.
You're welcome. Ryan, you also have questions?
No, I came a little late, so.
Oh, okay. I thought you have question.
Oh, sorry.
Kira, you are here.
Hi.
So great to see you.
You too.
All right. Okay. So yeah. So then this is your station model. Okay. All right. Okay. This is my pictures. Let's go to our discussion too. So once you know your discussion, okay, the second picture you are going to draw is a sample station model. Okay, you have more keys here. Our lecture presentation, draw a station model for a city. Can be the city you are living in or a hypothetical city. If you want to go, play with station model, you can just make it up, all different weather measurements. Okay, but I want you to follow the convention, draw something similar like this. Okay, but challenge your challenge your classmates to interpret it. Don't put anything there. Okay, just draw your picture. We need to challenge your colleagues. Okay. And then include your drawings in the initial pose. That's it. You just draw 2 pictures and then you finish your initial post. And the second one, I want you to pick your favorite person in our class. So basically come back, okay, to pick one your classmates. okay, one of your classmates to interpret his or her second picture, the station model, okay? Because we have amazing people in our class. We have people living in LA like forever. We also have people all over the country, even all over the world, okay? I know one student coming from Japan, and she will stay awake during the get up during the midnight to attend our lectures or other things. Okay, you will learn from her drawing. What's the weather look like today in Tokyo? Okay, or China or Saudi Arabia. Okay, many places all over the world. So I want to also use this discussion to build our learning community. Okay, stay engaged, make friends. That is why you're attending college. Otherwise, you just read your textbook. Okay, all right. So then how to interpret it? Well, just fill out those blanks in your replying, in your response. Okay, when you reply in your colleagues. Okay, so sky cover, the percentage, wind direction, wind speed, temperature, blah 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 blah. Okay, is that clear, guys? Okay, all right, so don't forget your initial post is due on Friday and the final post again due on Sunday. And on Monday, I'm going to grade it. All right, okay, I think that's it. So again, we continue the same module. So in my lecture presentation here, I think I have my lecture presentation. Oh, last week, let's see. I sent that to you. Let me go to my YouTube channel. I have YouTube channel. Okay, so there we go. I want to cancel this video. Oh, here we go. GEOG3, this one. Okay. We use the same lecture presentation like last time. So let me copy this. Let me send that through chat so you have. Okay. All right. Okay. So I will also include it in our lecture, the first page. Sorry, I lost myself here. Okay, so let me include this one here. Added it. Okay. Lecture video is here. All right. Okay, so it's right here. All right. Okay, so let me stop recording. For the in the rest of our office hour, I'm going to address your classmates' questions. So if you have other questions, you're welcome to email me, send me message. You can write a message right here at any time, guys. I am your teacher. Okay, so you want to ask your teacher questions. Okay, whenever. Again, our goal is to learn. I'm not here to just judging you like a machine deducting your points. That's not my job. My job is to make you appreciate, to learn, appreciate our beautiful atmosphere. Every day, when I look up the sky, my heart is melting. Oh my gosh, it's just so amazing. And I hope you can share, you can feel the passion, and you can share the same. Wow, yes, I see that. The same passion about our atmosphere, meteorology, and the weather and climate. It couldn't be more important, right? So good news, we're coming back to Paris, the agreement, right? And yeah, we need to understand our atmosphere better to build our better future. Okay. All right, so let me stop recording and I'm going to answer your people's question. All right, bye for now.